Assalamualaikum and good evening. We a student from University Technical Malaysia Melaka from the course of Technology Automotive, and we will present about the lab that we have done, which is the particle count analysis. Me, ZARIF, IKRAM, ZAKIR, and my group members, Muhammad Irfan, Danial, HEIDIZANI, ARMAN, KUSHAIRY bin ASWANDI, and NOOR, NAJIHA, BINTI, JUSRI, FAUZI, MENIN will present about the lab. The importance of clean oil cannot be ignored in any machinery system. Any machine component that experience contact and friction will generate wear debris regardless of the existence of lubricants. Particle count data is an invaluable part of predictive condition monitoring program. The particle count data can be used to ensure that component wear is at minimum and determine if hydraulic fluid is clean enough for reliable operation. The International Organization Standardization ISO has developed a cleanliness code that is primary piece of data review on most industrial oil analysis reports. The value of this code can help determine the overall cleanliness of the monitored program. This cleanliness code is regulated in ISO 44069 standard. Number of particles in three different size categories, i.e. larger than 4 micrometer, 6 micrometer, and 14 micrometer respectively, are determined in 1 millimeter of sample. Each size category should be counted with the absolute count converted to an ISO code using the ISO range code chart. The ISO code is a fantastic tool to use for setting target alarms and establishing a goal to achieve and maintain as it relates to system cleanliness. It is also the perfect value to use for key performance indicator (KPI), tracking, charting, and posting. However, the ISO code should play only a secondary role when it comes to evaluating used oil sample data. The objective of this lab is to analyze particles contamination in CVT gear oil and to classify the cleanliness level of the CVT gear oil. For the next part, I will pass the presentation to Irfan Danial.
So for the methodology, so first we start with the CVT oil preparation. So the degassing pump is connected to the power supply and the oil sample is placed in degassing chamber to remove the bubbles. Once the bubbles are eliminated, the pump is turned off, and the sample is ready for analysis. The oil sample is then transferred to the universal bottle sampler UBS offline suction point, while an empty bottle is prepared at the drain point. So for particle count measurement, so the UBS offline is connected, powered on, and the laser CM20 is activated. The ISO 4406/1999 mode is selected, and the operation control valve system is adjusted accordingly. The analysis takes approximately 2 minutes, after which the ISO code and particle count for respective sizes are displayed. For a second reading, the valve is adjusted and the analysis is repeated. The remaining oil sample is drained using the flush button, and the process is repeated for other samples, with system cleaning using N-heptane alcohol. Finally, the UBS offline laser CM20 and power supply are switched off. So to analyze or investigate the cleanliness level of the CVT oil, we use the average of particle count by size. For example, 4 micron, 6 micron, and 14 micron. We take the average particle count per size to relate it to the ISO code classification, and we can determine the cleanliness level of the CVT gear oil. So for the result and discussion, I'll pass it back to Zarif Ikram to explain it. Zarif?
Pardon me, I forgot to turn off my mic. Okay, as shown in the poster, this is the graph of particle size versus average particle count of new CVT oil and used CVT oil. The orange line is the used CVT oil and the blue line is the new CVT oil. We proceed with the discussion. The lab found CVT oils ISO code is 191714, missing target cleanliness of 161410. Controlling contamination crucial for reliability and lifespan of transmission system. Okay. The ISO code of the used CVT oil of this lab is 1917-14 based on the ISO 4406 code levels. It is determined by the average number of particles counted in the oil. The target cleanliness is 16-14-10, but the used CVT oil did not achieve the target. To achieve the cleanliness level target, controlling contamination is crucial in lowering component failure rates. Reliability and the lifespan of the transmission system can be increased by figuring out the ideal oil cleanliness level for a certain system and taking action to reach the target. For the next discussion, I will pass to our group members, ARMAN, KUSHAIRY.
Okay, so for the relation of particle count to the quality of oil and performance of transmission is the particle count in oil directly affects oil quality and transmission system performance by measuring the total contaminants in the oil itself, such as wear debris, dirt and dust. Higher particle count indicate poor oil quality and can lead to increased friction wear and component degradation. Contaminant can clog filters, impair lubrications, and cause system failure. Regular monitoring, analysis, and maintenance necessary to maintain low particle counts, ensuring optimal oil quality and the efficient operation of the transmission system. Low quantity of particle measured can be also utilized to assess wear because it's revealed the details about the particular component that are undergoing wear. So explanations to the number of particle counts for the increasing and the decreasing on used CVT gear oil. So for the increasing of the particle counts is because of the wear and tear. So over time, internal components of a CVT such as bearing, gear and clutches can experience wear and generate particles. These particles can mix with the gear oil, increasing the overall particle counts. Other than that, contaminant also is the reason for the increasing of number of particles for a certain oil. So if the CVT system is not properly sealed or if there is contamination during maintenance or repair procedure, foreign particles like dust, dirt or metal shavings can enter the gear oil, leading to an increase in particle counts. So beside that, degradation also is the one of the particular reason for the increasing number of particles, which as the gear oil age, it can degrade due to the heat, oxidations or chemical reactions. The degraded oil may form sludge or varnish-like deposits, which contribute to the particle count. So while the decreasing in the number of particles can be verified for the filtrations, which is if the CVT system has an effective filtration mechanism, it can remove and retain a significant number of particles from the gear oil. Regularly changing or cleaning the filter can help maintain a lower particle count. Other than that, flushing or replacement, which is if the gear oil is flushed or completely replaced, it can reduce the particle count. Fresh clean gear oil will have fewer contaminants compared to used oil. Other than that, improved maintenance, which is proper maintenance practices such as regular oil changes can help minimize the particle count. Fresh oil with the right viscosity and additive can provide better lubrication and reduce wear on the internal component, resulting in fewer particles. It is important to note that the particle count in CVT gear oil should be within the manufacturer recommended limits. High particle counts can indicate excessive wear or contaminations, which may require further investigations and maintenance to prevent potential damage to the transmissions. So for the next conclusion, I will pass it to NAJIHA.
So I will explain about the conclusions of the overall methodology and findings. So the particle count analysis performed on samples of hydraulic oil using the laser CM20 contamination monitor yielded useful information regarding the level of particle contamination and the sanitation of the lubricant. Observing particle contamination in the lubricant samples and classifying the level of purifiability were the intended outcomes of the experiment. So the ISO code classification examination of CVT or reveals particle contamination and oil cleanliness. It is essential for the proper operation and longevity of machinery system that the lubricant be clean. machine components that experience friction and contact will produce wear debris regardless of the presence of lubricants. Particle count data plays an essential role in proactive condition monitoring program as it serves to guarantee minimum component degradation and determine the sanitation level of hydraulic fluids for dependable operations. So the next one is the ISO code provide quantitative measurements of particle in specific site range. The International Organization for Standardization ISO has devised a sanitation classification ISO 4406-99 to evaluate the overall purity of monitored system. In 1 millimeter of sample, the particle count analysis determines the number of particles in 3 distinct size categories: more than 4 meter, more than 6 meter, and more than 40 meter. Using the ISO range code chart, these numbers are then converted into ISO code. And the last one is this analysis helps assess all conditions, system performance, and ensures optimal operations of the CVT system by analyzing particle count data and comparing it to the ISO code. Maintenance professional can determine the levels of particle contamination in the lubricant and make informed decisions regarding all changes, filtrations, and maintenance procedures. Regular monitoring of particulate data aids in ensuring optimal system sanitation, minimizing attrition, and maximizing machinery dependability and longevity. So in conclusion, particle count analysis provide essential information regarding the degree of purity and particle contamination in hydraulic oil samples. By adhering to ISO standards and utilizing the proper monitoring equipment, maintenance for professional can effectively assess the conditions of lubricant and take preventative measures to maintain system purity and avoid potential problems caused by the particle contaminations. That's all. Thank you.